Good morning, good afternoon, and good evening to wherever you are. I'm Noah Mack, and today we're going to be talking about the basics of the Aruba wireless ecosystem. Now, this is not going to be the most in-depth video. In fact, we're not even going to touch how things are configured, but this will give you a general overview of what does what in an Aruba Network's WLAN system. We're going to be going over the hardware models and specifications, including how to tell which model is which, the different software types and versions, some various deployment scenarios and where you might choose what solution, a few typical topologies that you'll encounter in the wild, and monitor and config flow for the Aruba OS controller ecosystem. So who am I? I am based out of Brooklyn, New York. I founded my managed service provider in 2018, and I have lots of experience with Aruba, Cisco, Unify, and Ruckus wireless solutions. I have over 100 APs out in the field currently from all of those vendors, and have been working with Aruba since 2022. So, when it comes to Aruba wireless hardware, there are three main categories: indoor, outdoor, and rugged. Indoor is going to be the most common one. When I'm looking at a model number, you'll see AP dash, in this case, XXX, and maybe a dash N. These are just placeholder values, as you'll see. So AP meaning access point, running in either campus or remote mode. We will get into that later. You might also see IAP, which means instant access point. We will get into that later. The XXX is the series, and the dash N is any special features. So let's expand on that. To date, there is about 5 main series. These are those XXX values. The 2XX is the Wi-Fi 5 Wave 1 APs. These were mainly released and sold from 2013 to 2017. The 3XX is Wi-Fi 5 Wave 2. I suppose I did not edit that, but 3XX is Wave 2. The 5XX is Wi-Fi 6, 2020 to present. Some of them are still being sold. The 6XX is Wi-Fi 6E, which was released in 2022 and is still being sold today. And then the latest 7XX is Wi-Fi 7, which started around 2026, 2025, and is still sold, obviously. Aruba was very late to the Wi-Fi 7 game, I'll be honest. Now, sub-series. So, as you may notice here, there are these X's remaining. These are where the sub-series goes. So, 03 is ultra-low cost. These are only in the Wi-Fi 5 and 6 APs only. X05, meaning any of these numbers, plus 05 is your ultra-low or your low cost, only found in the Wi-Fi 5, 6, and 6E series. X15 is medium performance. X25 is high performance. X35 is high performance. X45 is also high performance. And X55 is ultra high performance. Generally, what you're going to find is in the 03 and 05 series, these are going to be your 2x2 APs, optimized for low density environments. 15, 25, and 35 are going to be your 4x4 APs. And 45 and 55 are going to be either 4x4 or 8x8 MIMO APs, often with dual 5 GHz or 6 GHz. Now, the dash values, dash R or RP is a remote worker AP. This is not the same as a remote access point. Aruba used to have dedicated remote worker access points, and those were marked with the dash R. Dash P means PoE output, and dash H means hospitality. These are the wall mount form factor, and most of them have PoE output as well. Now, Before the Hospitality series, they had the separate remote worker APs, the -R, but since they've released the Hospitality wall mount APs, they've gotten rid of that, and you now use the Hospitalities as your remote worker APs. And in any of these subseries, bringing one of these digits down to a 4 means that it's external antennas. So for an example, an AP 325 is a Wi-Fi 5 Wave 2 AP with 4x4 antennas in the high performance category, while the 324 is that but with external antennas. Here are the models visually. Your 200 series are these sort of like older looking ones with all of the straight lines. Your 300 series are most often spotted with this kind of swoosh down the center of the AP. Your 500 series has like these little lines coming outwards and to the left of the AP, like almost like feathers. The 600 series has these swooshes again around the AP with 4 of them. And then the 700 series is this kind of geometric pattern. In terms of outdoor AP models, you have your 200 series, your 300 series, your 500 series, your 600 series, and your 700 series. I also made the mistake, the 300 series outdoors are also Wave 2. So let's say you're looking for a Wi-Fi 6 low density directional AP. So we'd start by looking at our 5 series, so our 500 series. You're looking for low density, so the middle number is going to be a 6. And then you're looking for a directional. In this case, I want a 7 because the 7s are a little bit more directional than the 6s. So I now know that I'm looking for a access point 567. So an AP 567. Now, if I wanted that in the instant version, I would want an IAP 567. And if I wanted to put this in a hazardous location, I would need to get the -EX. The lower density models look like this, and the higher density models look like this. Now, in terms of rugged APs, these are not quite outdoor APs, but not indoor APs. These are meant for like fridges or warehouses where you temperatures outside of regular AP operating, and maybe you need some level of water resistance, but it's not going to be like outdoors in the rain. This is a way more simple series. There's the 228, which is Wi-Fi 5 Wave 1, the 318, which is Wi-Fi 5 Wave 2, and then the 518, which is Wi-Fi 6. So far, they have not released a 6E or a 7 version of these rugged AP models due to the 6 GHz restriction with external antennas. Now let's talk about mobility controllers or branch gateways. There are 3 primary series when it comes to Aruba. The 7X series are your small branch mobility controllers. A mobility controller is essentially a wireless controller. These 7000 series support up to 64 access points, with the 7005 supporting 16, the 7008 supporting 16 while also having PoE output, 7010 with 32 APs and 12 PoE outs, and the 7030 with 64 APs. Now, the 7200 series are also mobility controllers, but these are more meant for large campuses. These support up to 2048 APs, and these can also run in the Mobility Master mode. Now, what is a Mobility Master? A Mobility Master is essentially like a private cloud host. So if you're used to Unify, this might be referred to as a cloud key. If you're from the Cisco side, this is like a Catalyst Center. Mobility Master is essentially managing campus or small branch mobility controllers. So the 7205 supports 256 APs, the 7210 supports 512 APs, the 7220 has about 1,000 APs, and the 7240 and 7280 have 2,048 APs. And at the time you set the 7200 series up, you can choose whether you want them to be mobility controllers or mobility masters. Now, access points can only terminate on the mobility controllers. You cannot connect a access point directly to a mobility master. Now moving on to the 9000 series, these are your next generation SD-WAN devices. You can convert them to be mobility controllers just like the 7000 and 7200 series, though these are really built for central. The 9004 can support 32 access points. The 9004 LTE is that, but a cellular version. The 9012 supports up to 32 APs with some PoE outputs, and the 9240 supports 2048 APs. It is worth noting that the 7000 and 72000 series can also be used as central SD-WAN appliances. They can be converted up, but the 9000 series is really the next generation, as the 7200 and 7000 series are no longer sold by Aruba. So moving on to the software side of things, there are three main operating system tracks. Instant OS, which is the wireless controller hosted on the AP, your traditional Aruba OS 6.x or 8.x. This is the mobility controller and mobility master architecture. And then you have Aruba OS 10, which is all central all the time. Now, let's get into the differences. Instant OS is really meant for small site wireless with support for up to 128 access points per virtual controller. The controller is on the AP. You do not need any other hardware. In addition, you do not need any licenses. You can manage multiple instant clusters through Central or Airwave. A couple of downsides, though, is Instant OS will not be receiving any APs further than Wi-Fi 7. For Wi-Fi 8 and above, those will be Central only. Also, with Instant OS, there's less hardware interoperability. For instance, on AOS controller 8.10, it supports Wi-Fi Wave 1 all the way up through 6E. 8.10 instant version only supports Wave 2 through 6E. In terms of AOS controller, these are your campus and branch wireless controllers. They support up to those 2048 APs. A controller appliance, so the mobility controller, can be hardware with the 7000, 72,000, or 9000 series, or they can be a virtual machine. Licenses are needed for these. These are also limited to Wi-Fi 7. They will not be receiving support for Wi-Fi 8 or above. The AOS controller software track also allows you to run multiple OS clusters at the same time. So for instance, if you have a mobility master running on 8.13, that can manage 8.13 and 8.10 mobility controllers. You can manage multiple mobility controllers through Central, Airwave, and the mobility master. And finally, the 9000 series, which I should really call Central, are just those, everything is Central managed. Licenses are no longer perpetual, they are subscription based, and Central will also support Wi-Fi 8 and higher because this is the direction Aruba is going. And these are more like SD-WAN focused devices. It's basically Aruba's version of Meraki and the Meraki dashboard. Now let's talk about licenses for the AOS controller. This is your mobility controllers and your mobility masters. Each access point gets a license. This enables the wireless network broadcast. The Policy Enforcement Firewall license is for monitoring, controlling, and restricting traffic and users with a policy assigned to the end user's device. These are per AP licenses. RF Protect is your wireless intrusion prevention and detection. These are also per AP. WebCC is web content classification. This is URL inspection and categorizing website types. Per AP, and these are subscription licenses because Aruba is constantly updating the URL profiles. Virtual Internet Access is per user. This allows a user to remote into a mobility controller network without using a remote access point. Now, the license for the Virtual Mobility Controller and Virtual Mobility Master are available in 10, 15, 500, and 1,000 increments and are perpetual. Note that for the physical mobility controllers and mobility masters, you do not need a platform license. Now let's talk about central licensing. This is way simpler. There's a subscription license called the Device Management Token. This is just your Meraki subscription equivalent. And then there's also service tokens, which are value-added services for APs and switches. These include things like Clarity, which is advanced insights into client health. Cloud Guest, which is a cloud version of ClearPass. ClearPass being Aruba's guest management and radius server. Web content classification, presence analytics, etc., etc. So, let's talk about some deployment scenarios. For small branch and small office, home office, you're most likely going to want to put in Instant OS or Instant On. A lot of people get Instant OS and Instant On confused. The main difference is Instant OS is on-prem and can be managed by Airwave, Central, or Mobility, and Instant On is cloud only. Now, for a campus with some remote sites, you're going to want to use AOS controller or Central. For a campus with many remote sites or a remote site only deployment, you're going to want to use Central. Note that AOS controller is approaching end of life in the 2030s, and you should be considering moving to Central. So let's talk about the difference between RAPs and CAPs versus Instant OS. So a remote access point is a campus access point remoting in remote AP mode. Now, a RAP uses a public IP or DNS discovery of the controller over the internet. A RAP supports traffic bridging at remote sites or tunneling the traffic. So let's say that at your remote site, like a employee's house, you give them a personal SSID that bridges all the traffic to their internet connection as a normal access point or home router would. And then you give them a corporate SSID that tunnels all of the traffic back so they have access to services only available at the main campus. A remote mesh access point is a RAP with mesh enabled. A campus access point is connected to a mobility controller or Central on the internal LAN. These use private internal IPs or internal DNS-based discovery. Again, they support traffic bridging at the AP or tunneling the traffic back to the controller. CAPs and RAPs are the exact same hardware. It just depends if they're outside of the corporate network or inside the corporate network. Now, the Instant AP is running the Instant version of the firmware. All APs must be running Instant firmware to be used in an Instant cluster. You cannot add campus APs or remote APs to an existing Instant access point deployment. Instant On is just the cloud. Let's talk about some topologies. Here is your typical Instant topology. You have your Instant APs here at our Soho deployment. You can manage them locally through a web GUI, or you can manage them through the internet via Central or Airwave. So this is like your very simple small office deployment. Moving on to a simple Aruba OS campus deployment, you have your campus APs inside the corporate network, which then go through your access layer switching and like core switching and whatnot, with the mobility controller and mobility master managing the campus APs. Then you also have some remote access points, so your wraps for your work from home clients or whatnot, that connect into the mobility controller over the internet. And the mobility controller and mobility master can be monitored for airwave as well. So let's expand on this mobility controller, mobility master kind of thing. So this is kind of the last example, but a little bit more expanded. This is really like multi-site oriented. So you start with your corporate network at your office. You have your campus APs managed by your office campus mobility controller. Now, the mobility master is sort of the star of the show here, as it's controlling this mobility master at your HQ, as well as your remote site mobility controllers. Now, where you might want to deploy a mobility controller at a remote site is when that remote site is a large enough branch to the point where it needs a higher density wireless, and you want the config to be perfectly synced with the mobility master at your main campus. One other thing to note is remote access points do not manage roaming very well. So if you have above 4 APs at a remote site, you should probably just put a mobility controller there. I should correct myself from a little earlier. Remote sites with a mobility controller do not have to be using the exact same config as the mobility controller on your main campus. Both these mobility controllers, both the campus one and the remote site, are just being managed by the same mobility master, making config templates significantly easier. You can also have your standard remote APs joining into the mobility controller anywhere. So let's talk about a central topology. This is very much like the Meraki way of doing things, or the Extreme Networks way of doing things, where you just plug the APs in, and congrats, they talk to the central dashboard. You can also do central on-prem for large AP deployments, and if you want, you can do a 9000 series SD-WAN gateway, though it's not required per site. So, sort of an example of a mixed topology where you might have instant APs, remote APs, and campus APs. Your campus APs are going to be inside your main campus talking to a mobility controller or mobility master, depending on the level of complexity that you want. Then your remote APs with this blue link will be going through the internet back to your main campus or data center, then back into that mobility controller. Then if you have some instant APs, those will be going through the internet and then to either central or airwave. From there, you will use central or airwave to make sure that all of the APs, be them instant or campus, are in sync and give you central monitoring. Now, last thing we're going to get into is the config topology when using a mobility master. Now, mobility controllers on their own are standalone appliances with really no way to sync their configs. The mobility master is what gives you multi-site configuration over multiple mobility controllers. The mobility master uses a folder-based system where you have your top folder and your subfolders. Here we have a little example where our top folder has an SSID of main being pushed down to controller 1, which is inheriting that SSID, but also has its own. Then controller 2 is also inheriting the top folder SSID main, but has its own WLAN setup as well. Then from there, we have another subfolder called, subfolder, with an SSID of main inherited from the top folder, and an additional SSID called sub, which is created within this subfolder here. Then controller 3 and 4 both inherit the main and sub WLANs, with the sub being pulled from the subfolder and the main being from the main top folder. And then these controllers also have per controller overrides. It's important to note that on every single controller in the stack, no matter what folder it's in, can have its own settings. Here I'm just simply demonstrating the kind of top-down waterfall templating system. And that's about it. That's Aruba Wireless, kind of summed down. Yeah, thank you for watching.